In living cells, the concentration of sodium is much greater outside the cell than it is inside the cell, and potassium is much greater inside the cell than outside. The sodium-potassium pump is the main mechanism used by cells in order to maintain the concentration gradient of these two ions. It functions by binding 3 sodium ions, followed by ATP, indicated by the star. ATP hydrolysis phosphorylates the pump and induces a conformational change. The phosphorylated form has decreased affinity for sodium, allowing the sodium to diffuse away. The pump binds 2 potassium ions outside of the cell, which causes release of the phosphate and induces a conformational change, which then releases potassium and allows the cycle to start again. The sodium which leaves the cell is used to bring larger molecules, such as glucose, back into the cell by moving down its concentration gradient using a carrier. The purple sodium glucose transporter functions by binding 2 sodium ions and 1 glucose molecule. A conformational change causes the sodium and glucose to enter the cell. Without a mechanism such as this, large molecules, such as glucose, would not be able to enter the cell. The potassium which enters the cell leaves through the light blue potassium leach channel, which is always open. This makes the cell more permeable to potassium than any other ion. The potassium leach channel, combined with the sodium-potassium pump, which removes more positive ions than it brings in, causes the cell to have a negative resting potential and allows the cell to manipulate the environment to suit its needs.